Hello ladies and gentlemen, welcome to the portal. Once again I'm back with another video. Today's lesson will focus on acids and bases. Okay guys, so before we can continue, I would like us to look at the outcomes, the learning outcomes of this lesson. So at the end of the lesson, you will be able to define acids and bases according to Arrhenius definition and according to Arrhenius theory and Bronsted-Lowry theories. Okay, and you'll also be able to give examples in terms of equations. Okay, so now on point number 2, we'll also define what an ampholyte is, or amphoteric substance. Okay, and we'll also discuss what amphiprotic and see if all these terms mean the same thing or not. Okay, because they can be confusing depending on the book that you can be using. Okay, but at the end of this lesson you will understand what is an ampholyte and what is amphiprotic substance. Okay, so, and we'll also name the common laboratory acids and bases, the ones that we commonly use, such as hydrochloric acid, sodium hydroxide. Yeah, so, and then after we have our list of common acids and bases, we will classify them according to their strength. Okay, we'll also define what is a strong acid, what is a weak acid, strong base or weak base. Okay guys, so now let's continue. Okay, first things first, point number 1. So let's define them. Let's define what is an acid according to Arrhenius theory. Okay, so now back in the days, during the discovery of acids and bases, Arrhenius discovered and came with a theory saying that an acid, when it is dissolved in water, it will increase the concentration of the hydronium ion in water. Okay, so now, okay, let me start by according to Arrhenius theory. Okay, so now Arrhenius definition solely relies on water, or what we can call aqua. Okay, so now if I have water here, let's say I have a beaker of water, right? So inside water, the water molecule, we know that is what is H2O, right? Okay, so now there's something that we call auto ionization of water. Okay, so now we will talk about that a bit later. Okay, so now auto ionization of water, it means that between the water molecules themselves act as acid and base. Okay, I haven't explained what is an acid and what is a base, but when water auto-ionize. Okay, so this is what happens. So between two molecules of water, okay, so two molecules of water that react, we are going to have what, a hydronium ion and what, and a hydroxide ion. Okay, so this is what is auto ionization of water. Okay, so now Arrhenius defined an acid in this manner. Arrhenius said that if you dissolve an acid, okay, if you dissolve, let me choose a nice color here. Arrhenius said that if you dissolve an acid, right? If you dissolve an acid inside water, right, the acid will increase the concentration of the hydronium ion in water. Okay, so now, meaning, how does it increase the concentration of hydronium ion in water? It means the acid itself must produce what, protons, hydrogen ions, so that when those hydrogen ions meet with water, they will form what, hydronium. So now the concentration of the hydronium ion in water will be increased, right? I'm saying it will be increased. Why? Because already, because of auto-ionization of water, there's what, there's a hydronium ion. Okay, there's concentration of hydronium ion and not concentration of hydroxide ion. Okay, so now he said that now acid, okay, let me write it here. Acid is what, is a substance that that increases the concentration, that is a substance that increases the concentration of hydronium ion in water. Okay, so now from the auto-ionization of water, as I've said, we have the concentration of hydronium. Okay, so but when we add the acid, this will increase, this concentration of hydronium will increase. How will this concentration of hydronium increase? Okay, let's take any acid. Okay, Ha. This H is the proton, and then this A is an anion. Okay, it's holding the proton. So if I add this water, this acid inside water, if I add it to water, okay, so now what is going to happen is that this acid, when it dissolves, okay, it will form what, it will dissociate to form what, H plus and what, and A minus. Okay, so it will form H plus and A minus, right? So this H plus, it will be attracted to the water molecule. Okay, so now it will be attracted to the molecule to form what, H and what, you see. So now this is the original water molecule, and then this is the H from what, from the acid. So but now notice that here we had a charge of 0, here we're going to have a charge of what, of +1. Okay, so now this is hydronium. Okay, so Now the proton went to the water molecule. Okay, so now what do we have? Plus what? Plus that negative ion. Okay, so we can see from this example that acid, this acid produces what? It produces this hydrogen ion. Okay, so after producing this hydrogen ion, is going to form what? It's going to form the hydronium ion, which will increase the already existing hydronium ion in water. Okay, so now this can be stated as follows, according to the examination guidelines. Okay, so according to the examination guidelines, Arrhenius acid is what? So what I'm going to state is similar to this. Okay, but let me also give you the ones from the guidelines. This is also Arrhenius. Okay, this is also Arrhenius acid. So Arrhenius acid, according to the exam guidelines, is what? A substance is what? A substance okay, so a substance that which produces hydrogen ions, which produces hydrogen ions, okay, which is H plus, right? Or hydronium hydronium ions in aqueous solution, okay. So a substance which produces hydrogen ions or hydronium ions in aqueous solution. So now what is the difference or similarities of this definition with what I've written above? Well, it's the same thing. If you check this definition that I've written in red, it says a substance that increases the concentration of hydronium ion in water. Okay, so now here, yes, we know, as I've explained, that in water already we will have autoionization. Okay, so meaning that although there's the water, there's also concentrations of hydronium ion and concentration of what? Of hydroxide ion. Okay, so now when an acid is dissolved in water, it will increase the concentration of the hydronium ion. How does it increase the concentration of hydronium ion? Okay, so now as you can see from this definition, a substance which produces hydrogen ions. Okay, so by producing hydrogen ion, it will increase the concentration of the hydronium ion, guys. So the one that you will write in your examination, it will be this one. Okay, so you will check your examination guidelines. Okay, but both of them, they are correct. Okay, so now what about a base? What is a base? Okay, let me take this nice and purple color. Okay, what is an Arrhenius base? So Arrhenius base is what? A substance which increases the concentration of hydroxide in water. Okay, so this one is similar to the one that I've written in red. Okay, so it increases the concentration of hydroxide ion in water. Okay, so how does it increase? Remember from autoionization, as I've written there, it will already from autoionization we have what? We have okay, we have okay, we have that. Okay, so a base, if I take a base, I add it to water. For example, I take what? I take sodium hydroxide pellets, and then I dissolve the pellets in what? In water. Okay, what will I get if I dissolve the sodium hydroxide pellets in water? I will get what here? What will happen? Okay, Na plus and what here? Okay, OH minus, right? Okay, so sorry about that. Okay, so now what will happen is that now I will have what? I will have a sodium ion and what? Hydroxide ion and what? And that water molecule. Okay, so now remember from autoionization, already there's concentration of hydroxide ion in water. Okay, so this acid, when this base, when dissolved in water, it will produce what? A hydroxide ion. Okay, so this hydroxide ion will increase the already existing hydroxide ion in water, right? So hence a substance which increases the concentration of hydroxide ion in water. Okay, so now from the guidelines, it is defined as something like this. So they say that it's a what? A substance which produces hydroxide ion, which produces hydroxide ion in aqueous solution. Okay, so this definition from the guidelines, it only tells you that the base produces hydroxide ion in aqueous solution. Okay, it does not include the auto ionization of water. Okay, so in later stages you are going to understand what is auto ionization of water. Okay, so now this definition written in blue and this one written in white, they are the same thing. Okay, so but this one requires you to understand auto ionization of water, and then when you understand auto ionization of water, and then you can see that is what a substance which increases the concentration of hydroxide ion in water. Okay, in order for it to increase the concentration of hydroxide ion in water, itself must produce the hydroxide ion. Okay, and then after that it will increase the concentration of hydroxide ion in water. Okay guys, so now there is another theory of defining acids and bases, which is what? Which is the Bronsted-Lowry theory. So now, why do we have many definitions of acids and bases? Can you take a guess? Okay. Whatever guess that you had, you can write it in comment section. Okay. So now, as you have seen that according to Arrhenius theory, Arrhenius only defined acids and bases using aqueous solutions, okay, which is water, using water. So he said that when you an acid, when it is dissolved in water, it will produce a hydrogen ion or what or hydronium ion in aqueous solution. Okay, so but we won't always work with aqueous solutions. We also have organic solutions, right? So that definition of Arrhenius theory is limited. It's only limited to aqueous solutions. Okay, so hence Bronsted and Lowry came up with another definition. Okay, that can accommodate that can try to accommodate both sides. Okay, so but this one of Bronsted-Lowry, it is defined using what? Using protons. Okay, using a proton. So this one is defined using what we call protons. Okay, so by now you know what is a proton. Okay, a proton, we are referring to what? H plus. Okay, a hydrogen cation. Okay, so what did Bronsted and Lowry say? They say that an acid is what? Is a proton donor. Okay, an acid is a substance that can donate a proton. Okay, that is an acid. A substance that can donate a proton. That can donate a proton. Okay, so in simple terms, in your guidelines, they just say it is a proton donor. Okay, so and then a base, according to Bronsted-Lowry theory, a substance that can accept a proton. So here we have what similar and what and different weights in the two definitions. So the similar thing is what? The substance that can. The first one here, this one is different. Donate. This one can donate. Acid can donate. What about the proton? Sorry, man. What about a base? A base can what? Can accept. Okay. So an acid can donate. A base can accept. So now what is being exchanged here? What is being exchanged is a what? Is a proton, guys. Okay. A proton is the thing that is being exchanged. So one substance can donate it and the other can what? Can accept it. Okay, so now we can also have an example that also involve Arrhenius way of explaining what is an acid. Okay, so now if here I can have an acid HCl, we know that from grade 11 that hydrochloric acid is a strong acid. Okay guys, so now if I can add hydrochloric acid to what? To water, what is going to happen, guys? What is going to happen is this. In water I will have this. I will have the hydronium ion plus what? Plus the chloride ion. Plus chloride ion. Okay, so I have noticed that many learners, they are being confused by balancing of the acid and basis reactions, because the reactions have charges. Okay, so now how does this reaction happen? Okay, I'll go to that. Okay, so before that I must first identify which one is my acid, which one is my base. So this HCl is my acid. Okay, this water is my base. Okay, so now here, this is what this is, my hydronium ion. Hydronium, it tells me about the pH of the solution. It tells me that the solution is what? Is acidic, because what? There's hydronium ion now that is being produced. So this one is what? Is a chloride ion. So now what happened here? If you can check, this acid had what? Had a proton. Okay, so this acid had a proton, and then now if you can check now on the right hand side of the equation, that Cl does no longer have a proton. So but where is the proton now? The proton was donated to water, you see. So the acid donated the proton to what? To water, and water accepted the proton to form what? To form hydronium ion. Okay, let's check how this happened. So now if I have HCl, okay, plus water, so I'm going to write my water in this manner, plus water. Okay, so now what is going to happen here? Okay, here we have a bond as well. So what is going to happen is that this water, it has what? It has two lone pairs. Okay, so now when this HCl donates this proton, where is this proton going to go on that water molecule? This proton is going to go to what? To the oxygen, right? Or it's going to occupy one lone pair. So it's going to go to what? To the oxygen. Okay, so now what do we have here? Now we are going to have OH, this lone pair above, this hydrogen, and what? We'll also have this this hydrogen. Okay, and notice this. Notice that when this H is going to the water molecule, it goes there without what? Without an electron. So it goes there as what? As a proton, right? So a hydrogen proton is what? It's a hydrogen atom that does not have electrons. So it only has what? a vacant shell or vacant orbital whereby electrons can be found. Okay, but then now, because it came here without any electrons, so it's going to share this one in these two electrons with what, with the water molecule. So because it did not come with an electron, so this water molecule is going to complain. It's going to have what, a plus. Okay, so it's going to have a positive now to form what, to form hydronium. So now, because the hydrogen left without any electron, where did the electron go to? The electron went back to what, to the chlorine ion to form what, it went to the chlorine atom to form what, chloride ion. So the electron that was supposed to be on what, on hydrogen, is now left with what, with chlorine. Okay, and the hydrogen went to the water molecule empty-handed, and then the water molecule shared its valence, its lone pair with the hydrogen. Hence, it is what, it is positive now. Hence the hydronium, and here the chlorine. Okay. So now, also we can also explain this in terms of what, in terms of Arrhenius, because we can see that here we have water. Okay, but now, because now Bronsted-Lowry theory includes the Arrhenius things of ways of acid and bases, and also something that Arrhenius did not discover. So because of Bronsted and Lowry, they say that acid is a proton donor and base is a proton acceptor. So now this can be said. So if I can have HCl plus what, plus plus sodium hydroxide, we know which one is an acid, which one is a base. Okay, so now what is going to happen here? We know that HCl, when in solution, forms H plus and what, and Cl minus. Okay, and what about sodium hydroxide? Sodium hydroxide forms sodium ions and what, and hydroxide ions. Okay, so what is going to be our product? So our product is that we will look at the charges. Okay, so positive will attract negative. Okay, guys, so you know from electrostatics that unlike charges attract each other and like charges repel each other. So now this positive charge, this proton, is going to be attracted to what, to the hydroxide. Okay, and then what about this chlorine, this chloride ion? So this chloride ion is going to be attracted to what, to this positive sodium cation. So what are we going to have now? We are going to have H and what, and OH, and OH. So, and then on the other side, what are we going to have? We're going to have this Cl, the yellow Cl, attracted to the sodium ion. Okay, so we're going to have the blue sodium attracted to the yellow chlorine. Okay, so this is how we form a product based on acid and base. Okay, so now according to Bronsted-Lowry, an acid is a what? Is a proton donor, and a base is what? Proton acceptor. So which one is an acid, which one is a base here? So this is an acid, this is a base. Okay, this is a water, this is a salt, sodium chloride. So now acid is a proton donor. It has this acid has donated this proton to what? To the OH minus. This OH minus has accepted this proton. Hence, by definition of Bronsted-Lowry, this base OH minus is what? Is a proton acceptor, because it has accepted a proton that was donated by what? By the acid. Okay, so now you will notice that when we add an acid to a base, we will have what? Salt plus water. Okay, you know this from grade 11 and previous grades. Okay guys, so let's check another point. Okay, another point is what is the ampholyte. Okay, so this ampholyte, what is this ampholyte or amphoteric substance or amphiprotic? Okay, so now so if okay, we are going to define ampholyte. Okay, so they say that ampholyte is what? A substance that can act either as an acid or base. Okay, so ampholyte is a substance that can act either as an acid or a base. Okay, so let me give an example. If I can dissolve HCl in water, what am I going to have? I'm going to have the hydronium plus what? Plus the chloride ion. Okay, let me include the states here. So I'm going to have what? I'm going to have hydronium plus chloride ion. So what happened here? We can see that this HCl has donated a proton to water, right? So because this HCl is an acid, it's a proton donor, right? And this makes water what? A base, a proton acceptor. Okay, so now what if I have another reaction whereby I have sodium hydroxide okay, let's use this base. Okay, let's say we have ammonia. Okay, let's say I have ammonia plus what? Plus water. Okay, so we know that ammonia is a base, right? We know that this is a base. So now water in this instance, it will act as what? As an acid. Okay, so now ammonia in water, it will form what? It will form ammonium ion plus what? plus hydroxide ion. Okay, it will form ammonium ion plus what? Plus hydroxide ion. So in both situations, water is present, but in the first reaction, water is a base, but in the second reaction, water is a what? Is an acid. Okay, so this ammonium, although it has what? It has 3 hydrogens, it will not be able to donate this H, this as a proton. Okay, but it can only accept, okay, when it is reacted with what? With water. So this water donated what? A proton to the ammonia to form what? Ammonia. Okay, so now this is what an ampholyte is: a substance that can act either as an acid or base. Okay, so here, according to Arrhenius, an acid is a substance when dissolved in water produce the hydronium ion, or we can say an acid is a substance which increases the concentration of hydronium ion in water. Okay, so yes, and also according to Bronsted-Lowry, this is an acid. Why? Because it is a proton donor. It has donated a proton to what? To water, and the water accepted the proton. Okay, so now even here both Arrhenius and Bronsted-Lowry definitions apply. So we can see that water in the first reaction acts as what? As an acid, as a base, sorry, as a base, and then in the second reaction acts as what? As an acid. Okay, so because it can act both as an acid and as a base, we say it is what? It is an ampholyte. Okay, so now this ampholyte can also be used, they can give you another name and say amphoteric substance. Okay, amphoteric substance. Okay, amphoteric substance. So ampholyte and amphoteric substance, they mean the same thing. Okay, but be careful, ampholyte does not mean the same thing as amphiprotic. Okay, so we have another term, amphiprotic. Okay, so if we are talking about Bronsted-Lowry definition only, then we can say, yeah, they are the same, but in general they are not the same thing. Okay, amphiprotic, what is an amphiprotic substance? So it is a substance which can donate a proton or accept a proton. So what is this now? This is almost the definition of ampholyte defined in terms of Bronsted-Lowry definition of acids and bases. Okay, so but the ampholyte and the amphoteric, they are what? They mean the same thing, those two, but they don't mean the same thing as this one. I don't want to go very deep into it because it might confuse you. All right, so there's another definition that we know. It is called Lewis definitions of acids and bases, which it is not covered in grade 12. So you know, now when they say amphiprotic, you say a substance which can donate a proton or accept a proton, or you can say a substance which can either donate or accept a proton. Okay, but if you say amphiprotic substance is a substance which can either act as a base or an acid, that answer will be wrong, because this amphiprotic does not talk about all the acids and bases definitions. Okay, so now what I want you to know is that this ampholyte is the same as amphoteric, so don't be confused. Ampholyte, amphoteric, but amphiprotic is something that is different. Okay, so it is defined as a substance which can donate a proton or accept a proton. Okay, so now let's classify. Let's check time. Okay, still have time. So let's name and classify acids and bases. Okay, and bases according to their strength, according to their relative strength. Okay, so now from the previous grades we have learned about acids such as hydrochloric acid, sulfuric acid, nitric acid. Okay, so these are the acids that are considered as strong acids, and they are commonly used in laboratories. Okay, so the acids that I'm going to write here, they are the ones that they are commonly used in laboratories, and they are the ones that they will ask you about most of the time in examinations. Okay, so now here, let me say acids. Okay, then this side I have what? Bases. Okay, then here I have strong acids. Okay, and then here I have weak. So this strong applies in both bases and acids, and this weak applies in both acids and bases. So okay, so now strong acids, what do we have? We have HCl, which is what? Hydrochloric acid, right? Hydrochloric acid. Okay, what else do we have? We have HNO3, which is what? Nitric acid. Okay, what else do we have? We have sulfuric acid. Sulfuric acid. Okay, what about bases? We have what? Sodium hydroxide. We have what? Potassium hydroxide. So and then now in weak acids, what do we have? The ones that they commonly ask about is what? Ethanoic acid. Okay, ethanoic acid. Okay, and then what else do we have? We have oxalic acid. And then what about weak bases? Let's start with the famous one, ammonia. And then the second famous one, sodium hydrogen carbonate. which commonly is named as sodium bicarbonate, and we also have potassium hydrogen carbonate. And then what else do we have? Again, we have calcium carbonate. Okay, so you have to know all of these acids and bases, guys, because they can ask you questions related to any of them, to any pair. They will pair an acid and a base. You must know which one is a strong, which one is a weak acid. Okay, so now let me go on to define what is a strong acid. Okay, okay, so what is a strong acid? Now a strong acid, we are looking at an acid that can ionize completely in water. All right, and we know that acids, they form what? A concentration of what? Of hydronium ion. Okay, so strong acid, a substance which ionizes completely in water to form a high concentration of hydronium ion. Okay, so what is hydronium ion? Is the H3O plus. Okay, so a substance which ionizes completely in water to form a high concentration of hydronium ion. Okay, so note this, you must note that the ionizing, okay, ionizes completely, okay, in water to form this high concentration, okay, of what? Of hydronium ion. If any of the key points are being omitted, you are going to lose all the marks. Okay, so what about a strong base? So a strong base, a substance which dissociates uh, completely in water to form a high uh, concentration of hydroxide ion. Of hydroxide uh, ion. Okay, so another keywords that you need to look at: it does not ionize. Strong base do not ionize. They what? They dissociate only, right? And they dissociate what? Completely in water to form high, also a key point, high concentration of what? Of hydroxide ion. Okay, so let's go to weak acid and weak base. So what is a weak acid? A substance which ionizes incompletely in water to form a low concentration of hydronium ion. Okay, now what about a weak base? What about a weak base? So weak base is a substance which ionize or dissociate, which ionize and dissociate incompletely in water to form a low concentration of hydroxide ion. You know that hydroxide is OH minus, okay, of hydroxide ion. Okay, so let's see if we still have time. We still have 3 minutes here. We are recording a 1 hour lesson. Sorry about this, that this lesson is taking longer, but it's equivalent to what, to 2 classes. It's something which could have been done at a faster rate, but I've noticed that most of the learners they are slow. Okay, so this is a lesson that can be enjoyed at a slow pace. Okay, so now we have covered all the learning outcomes of the lesson. Okay, so now what is ionization? When we say acid ionize in water, okay, why do we say only acids ionize in water? Okay, so ionization. Okay, so ionization of water means that there's a reaction with the water molecule, guys. It means that. Okay, so so it means there's a reaction with water and molecule. So if I say now an acid, okay, an acid is what? Let's say for example we take HCl, okay, HCl plus water, okay, HCl plus water will give us what? Will give us hydronium ion plus what? Plus chloride ion. So you can see that this water molecule, water was changed to what? From water to what? To hydronium. So this water molecule changed to hydronium. Okay, so there was a reaction between the HCl and the water molecule, hence this ionization. Now what is dissociation? Dissociation simply means the bond between the a base, let me say sodium hydroxide plus water. Okay, so dissociation simply means that the sodium will separate from the hydroxide only, but there won't be any reaction with water. Okay, here's how we can prove it. So now this sodium hydroxide, when it is dissolved in water, we'll have sodium hydroxide, we'll have sodium ions plus hydroxide ions, right? Plus water. So there will not be any reaction with water. Okay, but now if we can do a net reaction of this reaction here, we will notice that water here is what is a spectator, something that is a spectator. So no reaction is happening towards, so we can omit it in the reaction. Okay, so now it shows us that dissociation of this base is what is sodium plus, okay, and what, OH minus. Okay, so this is dissociation, and this is what, this is ionization, because water molecule was changed from water molecule to what, to hydronium, so hence it's ionization. And then here dissociation, the water molecule was not changed. Okay, so strong acid and weak acid, they ionize. Okay, but the bases, the what, the strong base dissociate, so it dissociates like this. And then you will notice that when we go to the weak base, they say the weak base, it what, it ionizes and what, and dissociate. Okay, so if you can check ammonia, for example, let's see if ammonia ionizes or dissociates, right? So ammonia plus water molecule, so what do we get? So we get ammonium ion plus hydroxide ion. So what happened? If you can check this water molecule, it was changed from being a water molecule to what, to being a what, a hydroxide ion. So there was a reaction between the ammonia and what, and the water molecule, hence there's ionization. Okay, so this base, this weak base, there's ionization in this weak base. Okay, but there is no dissociation here, there's only what, ionization. But if you can check other types of bases, let's say you check calcium carbonate in water, what is going to happen? So what will happen is this: we'll have calcium. Okay, let me start this side. Okay, so we'll have this calcium will dissociate first to form what, calcium cations and what, and carbonate anions. Okay, so now we have our water molecule there. So what is going to happen? What is going to happen? So here we will need two water molecules. So what is going to happen here? What is going to happen is that after this weak base is added into water, it will start by dissociating first, which is to separate to form ions. Okay, after dissociating, it will ionize. How will it ionize? This hydrogen will be donated to this carbonate. Okay, so remember this carbonate needs what, 2 protons. Okay, so to have a charge of 0, so this proton and this proton from 2 water molecules, they will go to what, to the carbonate. Okay, to form what, to form what we know as what, carbonic acid, right? Carbonic acid, right? So now carbonic acid plus what, plus calcium cations. Okay, So you'll notice that carbonic acid is not a very stable acid, right? So this carbonic acid, it decomposes easily, and when it decomposes into what? Carbon dioxide plus water. Okay, so this decompose into carbon dioxide plus water. Okay, so now it means now the reaction we have what? We have and what? And 2 hydroxide. Remember that this hydroxide ions, when these water molecules, when they donate the hydrogen protons, each will remain as OH minus, okay, plus 2 OH minus. Okay, so in full the reaction looks like this: calcium carbonate plus 2 water molecules give us what? Give us calcium cations plus 2 hydroxide ions plus what? Plus carbon dioxide plus water. Okay, so now we can check if this is balanced. Okay, we can check if this is balanced. So now if you can check the equation, so it's balanced. So just that I wrote it like towards the end. Okay, so it's what? In full, it's calcium carbonate plus 2 water molecules giving us what? Calcium cation plus 2 hydroxide plus carbon dioxide plus water. Okay, so one thing that you will notice is that the carbonate bases, they will release carbon dioxide plus water, okay, when reacted with an acid. So if you can check, everything is balanced. We have one calcium, we have one carbon, we have one carbon. How many oxygens do we have? We have 3 here, then 2, so we have 5 oxygens on the left. In here we have these 2, 2 plus 2 plus 1, it's 5. Okay, what about hydrogens? We have 4 here, and then we have 2 here, and then we have 2. So the equation is balanced. So but my point is, because here the calcium carbonate dissociated first, right? And then what happened to the water molecule? The water molecule changed from being a water molecule to form what? To form hydroxide ion. So there was dissociation and what? And ionization. Okay, so you must keep that in mind, that weak bases, they dissociate and ionize. Okay, or others, they only ionize but do not dissociate. For example, like ammonia, right? So but calcium carbonate, it dissociates and what? And ionize, okay, at the same time. So thank you guys. Sorry for the long video, but this was very important, because I have noticed that many learners, they get confused when it comes to these things. Okay, so thank you guys. Let me see you in another video. Okay, thank you. Don't forget to like, share, and subscribe. Ciao.